I will stick around for another, however long it takes, but you guys are free to go. And enjoy your,
Thank you, Professor.
you're welcome. And enjoy your sprint back until finals week. Hopefully we are just about done. Let's see.
Professor?
Yes.
Those two methods that you showed us,
For
what's the difference between the two?
for what? For Fibonacci?
Yeah, for Fibonacci.
I'm sorry, for factorial?
Yeah.
Okay. So the first method is actually oh, I got to kill this before it'll. Okay, so let's go back to our. Okay, so this is the first factorial function, right? This is a recursive function, right? We have a base case, n equals 0, where we bottom out and just return the value we know it has to be, which is 1. And then we have another case, another step, that's the recursive case, right? For the first recursive case, well, the factorial is n times the simpler problem, which is the factorial of n minus 1. So this is a recursive function. For the other one, let's get the one that was actually correct with the correct variable names. This is a non-recursive version of the same thing. Instead of generating the value recursively, what we do is we create a list. We put the base cases into the list, right? So fax sub 0 is the factorial of n equals 0, and we calculate that and we just put it into the list. And then as we go along, instead of recursing, we're just in an iterative loop. And every time through, we add the next value onto our fax list, right? So as we go through this with v equal to 1, we append onto our fax list 1 times the factorial of 0. This is non-recursive because this is not a function. This is just a local variable.
So it's appending.
You're fading.
So it's appending the value of the range. Just, like, let's say you put, I don't know, 3 in there. You put n as 3.
Yep.
So for v in range 1 through 4.
Right. So it would generate the values for 0, 1, 2, and 3. Right. That's 4 values.
Mm-hmm.
Oops. Did I have that right? No, that's right.
So, yeah. So v would loop through. Yeah, it would loop through that many times and append it to the list.
Yep.
Okay.
Okay. So this is iterative, and the other one was recursive. And the point was just to show you that you could generally, we'll get into the flattening, which is a little bit harder to do this way. But generally, you can convert for most algorithms, there's a simple way to convert a recursive algorithm into an iterative algorithm. Now, when we get to flattening and some tree traversals, it turns out that trees are actually, and fractals are actually recursive structures. So it is much harder to convert those to iterative algorithms. So we'll just give you the recursive ones for those.
Okay? So why did you put 1 in the list initially?
Because that's our base case. We know what the factorial of 0 is, right? And we need the factorial of 0 to calculate the factorial of 1.
I see.
Right? So this is our base case. Right? Just like for this is our base case. So instead of returning it, we're just keeping it in the list.
Okay, I think I see.
Okay.
Is like one method better than the other, or is it like?
Well, again, that there's trade-offs. If you're studying things, the recursive function may have interesting properties or may allow you to analyze it better. Or it may just be the easiest thing you come up with when you're thinking about it. So, if you're looking at the hierarchy of things we need to do with a function, you choose different implementations based on how important readability, understandability, complexity, and speed work together. So if you want a nice, concise way to express the factorial function, well, this is exactly the mathematical formulation. So it's easy to understand. It's really easy to implement, assuming you understand recursion. But it may not be as fast as an iterative version, right? Because this call is more expensive than just iterating through a loop. Fibonacci, it's even worse because of all the extra work. But again, maybe the recursive one is fast enough for what you're doing, and understandability is more important. So, there's never is A better than B. It's, given my constraints, which one is better for my application. In general, you want to avoid things that blow up. But it gets slowed too fast. But for teaching this course, for example, we really love showing the recursive stuff because it illustrates recursion. All right.
Yeah, that makes sense. Thank you, Professor.
You're welcome. Any other questions?
Hi, Professor. I have a question.
Sure.
For the factorial recursion that you have on the console right now.
Yep.
When you run that, does it return a value, or does it return the value? Does it start returning the values after after the recursion has finished, in terms of when the n goes to
Right.
0?
Good question. So what happens is, let me pop this, see if this will pop into here. Yeah, good. Okay. Okay, so, right, let's look at what happens. We come down here, we hit our factorial function, right? Our base case, we're not at our base case. So now we have to return n times the factorial of n minus 1. Well, we can't actually complete this line, right? We can't return anything here until we've actually calculated this, right? So before we execute this return, we have to gather all the information we need on this line. So the first thing that's going to happen is we're going to call the factorial on 4, and then, of course, the factorial on 3, factorial on 2, factorial on 1, factorial on 0. For 0, we don't have any more information we need, right? We'll just come down through here, and we can execute this. So the first return we're going to hit is going to be here, and the first value we're going to calculate is going to be the factorial of 0, right? And we're going to return that to this position in the factorial of 1, right? So now we have, we're in the n equals 1 case. We know what the factorial of 0 is. That's the return value being returned to us. So we have all the information we need to complete this line, and now we can return the value for the factorial of 1. And again, now this comes in. So now the factorial of 1 is 1, n is 2, so now we can return 2 to the n equals 3 case, right? 3 times 2 is 6, so we can return 6, etc. Okay? So, so we don't actually calculate this value until we've gone all the way to the end and figured out what the value of the base case is, and then walked back. Does that answer your question?
Yeah, it does. Thanks.
You're welcome.
I also have a question.
Sure.
But it's about the nearest user function on exam.
It's about the what?
It's about the nearest user function for exam 3.
About the nearest. You're really fading out. I'll listen to it, but it's likely I'm going to ask you to post it to the discussion forum. But let's hear it. What is it?
So the absolute value for the nearest user function, I made a list of like all the scores for all the customers in the dictionary, and I'm comparing them. So I'm like doing the score of the user inputted score, and then I'm looping through that list, and then I'm comparing them. But I'm taking the absolute value, and I don't know what it should equal for it to be nearest. So like I'm taking the absolute value of the score that the customer that was inputted in the score of like all the scores that were in the list, and then I'm subtracting them, and I'm finding the absolute value for them, but I don't know what the absolute value should be for that to be the nearest.
It has to be closer than everybody else.
Okay, so like it just the next closest score is the nearest score.
Yes.
Okay, but then there's more than one.
Yeah, that's in.
There can be more than one.
Yeah, I think that's answered in the statement. Let me read it. But I'm pretty sure that that's in the exam. Give me just a second here. Okay, exam 3. Yeah, it's answered in the second paragraph of Part B. I think. Add code to your main to print all closest matches in sorted order, along with a recommendation for the movie that the nearest user ranked highest.
Yeah. So, but there's one of the outputs. There's no similar user or recommendations.
A few more example runs show that if the nearest users have the same highest ranked movie as the current user, then the program must print a message with no recommendations.
Oh, okay, okay. Okay, I get it now.
Yeah, okay. I mean,
So
it's
the
in
next
there.
nearest.
Yeah.
Okay, just the next nearest. Okay, thank you.
Okay, sure. Anybody else? All right. Thank you all. I'm going to shut down the recording now, and then I will work on getting your all of this uploaded. Have a nice day, everybody. Welcome back. Thanks, Kristen.